All right, section 5.1, we're going to be going over polynomial functions. I do want to kind of take you through the textbook and at least point out many of the terms and properties that we're going to be going over. Some of them may be just a little tough to kind of go through it, but I'll try to explain it so that it's easy to digest. So a polynomial function is in one variable, so you'll have one letter, namely x, and these other letters you see, they will be numbers. So this an and an minus 1, these are like an index counting. And what those are, those numbers are called, those are constants, what they're called coefficients. The n up at the top is the exponent, and that is going to be an integer, a whole number, and it has to be greater than 0. So basically we want to have counting numbers. The leading coefficient is the one out front, which has the biggest degree, and the degree is the largest exponent. So let's look down here at the bottom. They give you some examples of identifying a polynomial. Mainly what you want to look for is that you have numbers and one variable. Your exponents are whole numbers, and this would be a polynomial. This one would be a polynomial out of order. This one would not. Okay, a square root would be defined as a exponent of less than 1, like a fraction, and we can only have integers. So the square root of x can also be written as x to the 1/2 power. So this square root of x is equal to x to the 1/2. So having a number up here that's not a whole number is violating the definition of what it means to be a polynomial. So that wouldn't be. So if you have any exponents that are not whole numbers, or even if you have division with a variable in the bottom, so the fact that we have an x on the bottom is a problem. We can have a number in the bottom. This 1/4 is okay. This is not. So I think the rest of these are polynomials. This is just factor form. So you got to be able to identify a polynomial, several terms that they go through with you. We also, well, I guess I'll go to the next one. This is talking about the degree. This has a degree of 1. This has a degree of 2 because of the exponent of 2. This is a degree of 3, and this is a degree of 4. So the largest exponent, they're showing that here. And then we're going to start talking about end behavior, looking at the end of the graph. So we'll see a few here. So these are properties of power functions when we have these polynomials. And this says if you have xn and the n is even. So up here you can see this is x to the 8th, x to the 12th, x to the 4th. All of those are even. Your endpoints will be going in the same direction, either both up or they will be going both down. So the way you tell if they're both going up, and I think it should say that is if your leading coefficient is positive. So let me see. We have even function. The domain is all real numbers. The graph always contains these points. Exponent n increases in magnitude. Okay, x is less than -1 or x is greater than -1. So the end behavior. So this is just dealing with the positive integer. As we go to the left side, negative infinity. So x is going this way to the left. These lines are going up. So it says this graph, the y value is going toward positive infinity. It's going up. This one says as x goes to the right side, so as x is going to positive infinity on the right side, also your graph is going up toward positive infinity. So this is a positive even integer. So that's what they mean when they say positive. That is the term out front. And these will be understood as positive ones. Now, we also have end behavior of a positive odd. Okay. And then you see a picture here. So positive goes up on the right and negative goes down. So these do the same thing. So if it's negative, as I'm going to the left, it's going down. And then as I'm going to the right, it's going up. So that is positive odd. We also need to look at negative. So this have this graph right here. This has a minus x to the fifth. So x to the fifth is odd and it's negative. So this would do the opposite. The left would go up and the right would go down. It'd be opposite of the positive. It would flip. So we'll kind of do some of those in practice. We also want to talk about what it means to be a real zero. So this definition just says if you have some number r, which is a real zero, we have these following properties, or these are consequences. And zeros have different names. They might call them zeros, they might call them solutions, x-intercepts, roots, many different names. But these points where it crosses the x-axis is when the y value is 0. That's what they mean, zeros. And they're also x-intercepts. But you get these following properties. R is a real zero. You get that R is an x-intercept, so it just matches the same thing here. You get that x minus r is a factor. So if negative 3 was a 0, when you do x minus negative 3, you would get this x plus 3. It would just change sign. So x minus r is a factor, and you get that r is a real solution. So we'll be using that property as well, which you'll see more as we get into it. And then we also have some factors, let's say x minus r, and it could be repeated. So multiple real zeros is what we call multiplicity. So if you have like some factor x minus r raised to like the second power, third power, that's what we call the multiplicity. It's repeated. Like this example here, x minus 1/2 has a fourth multiplicity. And then we get some properties about even and odd multiplicity. So if you see even multiplicity, the number doesn't change sign from one side to the other, and the graph touches. So like here, the way that this graph goes up and touches the x-axis and then goes back down, that would be the indication of some higher multiplicity. So like x plus 1, that root is -1, the opposite, and it just touches. Now if we have an odd multiplicity, the sign will change from one side to the other of r, and it will cross at r. So if, they might show us another example. The way this one crosses, the 0 was 2, and we can see here x minus 2, that's an odd power, so it will cross. And if it had like a 3 or a 5, it would be the same. And then we talk about turning points here. So the number of times, at least the maximum number of turning points any polynomial will have, will be equal to the degree minus 1. So n minus 1, whatever your turning point is. And that is the most. That's not saying how many turning points it will have. It simply means at most. So if we have a degree 5 polynomial, they show you 5 minus 1 will be 4. So at most, it will have 4 turning points. What do we mean by turning point? Well, if we look at this graph here, going left to right, so this, I'm looking at B. As I go left to right, this graph is going down, and then it turns and goes up. So that's 1, and then it's going up and turns and goes down. So this graph will have 2 turning points. So that's what we mean by turning points as a visual. And then I think that might encompass all that we'll talk about here. And so at this point, they just give you a summary. We'll go ahead and begin some of the examples in my math lab.